Hello, good morning everyone. Today I would like to share with you a topic on inverse discrete Fourier transform. First of all, I would like to share with you an example using the DIF technique. So if you look at this question, x dftk is equal to 4, negative 2j, 0 and 2j. So calculate the value of xn using the DIF technique. And the origin is at the value of 4. So if you look at this question, okay, how many samples is it? So n equal to 1, 2, 3, 4. So n equal to 4 samples. So n equal to 2, then 2 power of how many equal to 4? So 2 power of 2. So this means that this is the 2 stages. Okay, stage. You have 2 stages. Okay, for 2 stages of the butterfly, we need to draw 2 columns and 4 lines for 4 samples. Okay, 2 stages means 2 columns and 4 lines for 4 samples. So I have drawn 2 columns and 4 lines. So I name it as a stage 1 here, and this is the stage 2. Okay, and then you have the value of x. You name the binary here starting from the left hand side. So you have x0, x1, x2 and x3, and then the binary will be 0, 0, 0, 1, 1, 0 and 1, 1. So don't forget, at the right hand side is a reverse order of binary number, and on the left hand side, so I will get 0, 0. This is the reverse is 1, 0, whereas this one is 0, 1, and this one is still you get 1, 1. Okay, and you rename it. So this one is based on the order is x0, this one is x1, whereas this one is x2, and this one is the x3. Okay, so if you look at your question, your x dft k is 4, negative 2j, 0 and 2j. So this means that this side is referred to the x dft. Okay, x dft k. Okay, x dft k. So therefore, if you want to know the answer, we must start with we must put the x dft k value at the right hand side first. So okay, I put the value first. So this is 4, and then x1 is referred to minus 2j, and then x2 is 0, and x3 is 2j. Okay, inverse Laplace transform, right? So the question given the x dft k, and you want you to find the xn. So if just a discrete Fourier transform, we're starting from the left hand side, okay, and then you get the value of x dft k. If the question given is xn, and you'll find the x dft k. Now for the inverse Laplace transform, inverse discrete Fourier transform, you will need to the question given x dft k, and you will need to find the xn. So this is the things. So now we can start to find the stage 1. Stage 1, so we have the formula equal to 2 power of m minus i. Now total stages is 2, so m is equal to 2, and I is equal to 1 because you are talking about the stage 1. So 2 power of 2 minus 1 equal to 2. So when p equal to 2, you have the value q is 0 and 1, 2 value. Next, you find the t. T is equal to 2 power of I minus 1, okay, and multiply with q. So now the first t value is t, I name it as a t1, okay, and then 2 power of I is the 1 because it's stage 1, so 1 minus 1 multiply with q. The first value of q is 0, so you multiply with 0, and I get 0. And then for T2, again 2 power of 0 minus multiply with the second value of Q, that is 1. So multiply with 1 and you get 1. And then next I want to find for W 0, okay, because the T is the 0, so a W 0 is equal to exponent minus J 2 pi T over N. The T now, but the first T value is 0, okay, divided by N. N is equal to 4 because of 4 samples. So exponent 0 and this is equal to 1. And then W1, because the value of T2 is 1, so W1 equal to exponent minus J 2 pi, the value of T is 1 divided by 4, so you get exponent minus J pi over 2. So this will equivalent to minus J. So this one, how to get minus J? You can, okay, equal to cos pi over 2 minus J sine pi over 2. Then you can get the value of minus J. Okay, next we talk about the stage 2. Let's calculate for the stage 2. So stage 2 again, we have the P equal to 2 power of M minus I, and then the M is total stages, you have 2, and then the current stages is referred to the stage 2, also 2. So 2 power of 2 minus 2, you get 2 power of 0, then it's equal to 1. And then when P equal to 1, sure the Q is only one value, that is start with 0. And then next is start with T equal to 2 power of I minus 1 times with Q. Okay, so I, since I is 2, so 2 minus 1 times with Q is 0, then you will get 0. Okay, and W0 equal to exponent minus J 2 pi T is 0 divided by 4, so exponent power of 0, this is equal to 1. So this is the calculation for the stage 1 and stage 2 for the W, the Treader factor. Okay, next we would like to find for the value. Okay, next just we start with the stage 2 first. Okay, this is because we have the value of XDFT at the right hand side, so we must slowly want to get the value from starting from, we have the value here, so we need to get the value here, and then for finally we get the value of here, xn. So we start with the right hand side to the left hand side. Okay, okay, before we go to the calculate for the stage 2, the butterfly, we must know the we must know how to draw the closed line. Okay, as I mentioned to you in the DIF technique, so for DIF technique we have the, if n equal to 4 samples, so we have the closed line is x0 close pair with the x2, and okay, and x1 pair with the x3. Okay, and then also the same for the stage 2. Okay, x0 will pair with x1, and then x2 will pair with x3. Okay, now sim complete. So we start with the stage 2 first. Okay, stage 2 using the simultaneous equation. Okay, so just now we have the example of A and B, and this one is A plus B. So this is the formula used to find the value WT. So make sure this one is the facing downward of the WT. Okay, so you go back to the diagram. If you see here, it is 4 0. Okay, 4 0. This is assumed is the A and B. So A and B, A plus B. Okay, so for this value is A plus B equal to 4, whereas this one is A minus B multiply with the WT. Okay, equal to 0. So from the calculation just now, this is the W0 in which is equal to 1. This is also the same, W0 equal to 1. Whereas for the stage 1, W0 is equal to 1 and W1 equal to minus J. Okay. And then we follow this one. So you have A plus B equal to 4 and A minus B and WT is equal to 1 equal to 0. Okay. This is referred to the butterfly. Okay. A plus B equal to 4 and A minus B multiplied with WT equal to 0. This is exactly what I brought here. So I assume this is equation 1, this is equation 2. So this is a quadratic equation. So I have A, I want to eliminate the value of B, so I can A plus 1 plus 2. So you have 1 plus with 2, then I get 2A. A plus A, you get 2A equal to 4 plus 0, you get 4. So this one I can eliminate because B minus B, you get 0. Okay, so A is equal to 2 and B, I substitute the value, I get the B equal to 2. Okay, A is equal to 2, B also equal to 2, so you get the answer of 4. So the A is 2 and B is also 2. So I can write down in the diagram, and here I put A equal to 2, B also equal to 2. Next is a C plus D equal to, okay, we go back to the diagram. Okay, C plus D equal to minus 2J and C minus D multiplied with 1 equal to 2J. So this one is minus 2J and C minus D multiplied with 1 equal to 2J. So this is equation number 3, this is equation number 4. So 3 plus with 4, I will get 2C, okay, equal to, so this one D minus D is equal to 0, and then minus 2J plus 2J is also equal to 0. So I get 0 here, so C equals 0. And then I substitute the value of 0 into C, then I get D equal to minus 2J. So I finished the stage 2. So now let's transfer this value C and D into the diagram. C I get 0, D I get minus 2J. Now let's calculate for the stage 1. Okay, so stage 1, we look at the pair x0 and x2. So for this value is A plus C, okay, A plus C equal to 2 and A minus C multiplied with W0 equal to 0 here. Okay. A plus C equal to 2, so I assume this is 1. And A minus C multiplied with W0 equal to 0. So this is equivalent to, okay, I assume this is equation 2. Okay, A plus A, equation 1 plus with equation 2. Okay, equation 1 plus with equation 2. I will get 2A equal to 2 and A equal to 1. Okay. And I substitute the value of A into the equation and I get C equal to 1. So now the value A equal to 1 and C also equal to 1. Now I transfer back to the diagram. A equal to 1, C also equal to 1. Okay, next question is I pay with x1, pay with x3. So this one, B plus D equal to 2 and B minus D multiplied with minus J equal to minus 2J. So B plus D equal to 2 So equation 3, and B minus D multiplied with W1, this is equal to minus 2J. So when I rewrite, I have B minus D minus multiplied with minus J equal to minus 2J. So this is minus BJ plus DJ. Okay, this is equation 4. So if you look at here, this is B plus D equal to 2, and this one is the minus BJ. So this means that if I want to do the operation plus or minus, equation 3, I must multiply with J, then only I can do the operation of plus or minus. So therefore, equation 3, okay, this equation 3, I multiply with J. So I get BJ plus DJ equal to 2J. Now, all have a BJ, DJ, so I can do the operation. So this is, I assume this is equation number 5. And equation number 5 plus with equation number 4, so I get BJ plus minus, so minus BJ, so you get 0. Then DJ plus DJ, I get 2DJ. Okay, and then 2DJ minus 2J, 2J minus 2J, you get 0. So you get 0, then D, you get 0. Then I substitute into equation number 5, I get BJ plus DJ equal to 2J. And DJ, I get 0. So B equal to 2J by 2 divided by J, this is equal to 2. So therefore, the Xn is equal to A, B, C, and D. So A, B, C, and D, C and D. So D, we can write down the answer. D is equal to 0 and B is equal to 2. We can go back to the diagram. So B is equal to 2, D is equal to 0. So therefore, Xn, so this one is the Xn. So Xn is X0, X1, X2, X3. So we can take the value of 1, 2, 1, 0, and origin is the X0. So this is the answer, 1, 2, 1, 0 for the Xn. Next, I would like to show you another example. Okay, given that the XDFTK is equal to 14, 2 minus 2J, 2, and 2 plus 2J. Using the DIF technique, so calculate the value of Xn. Okay, now, in the question, how many samples? Okay, yes, n equal to 4 samples. 4 samples, this means that the 2 power of 2, so it's 2 stages. For 2 stages, you need to draw 2 columns and 4 lines for 4 samples. So I name it here as stage 1 and this is stage 2. Okay, so for the left hand side, I name the Xn, so X1, X0, X1, X2, and X3. For the binary, we have 0, 0, 0, 1, 1, 0, and 1, 1. So similarly, at the right hand side, we still need to name the right hand side. So it's a reverse order for the binary. So this is 0, 0, 1, 0, 0, 1, and 1, 1. And then this is actually is a XDFTK 0 and XDFTK 2 and XDFT 1 and then XDFT 3. From the question given is 14, 2 minus 2j plus 2 plus 2j. So we need to fill up here. So 14, 2 minus 2j, okay, we need to follow the XDFT0, XDFT1. And XDFT2 is 2 And next one is 2 plus 2j. Okay. And for the butterfly of 2 stages, you already know that for 2 stages is the x0 pair with x2. So you draw the cross line, where the x1 pair with x3. And then for stage 2 is x0 pair with x1 and x2 pair with x3. Okay, and this is w0 and w1, and this one is w0. Okay, now we want to find the p, q, and t, and also w for the stage 1. First of all, we find the p first. Okay, p is equal to 2 power of m minus I. So it's 2 power of 2 minus 1. So it's 2. And q is referred to 2 values. So start with 0, 2, and 1. And t is referred to 2 power of I minus 1 times with q. So the first t value is t1. T2, I is referred to first stage, so 1 minus 1 times with 0, so you get 0. And T2, the second value of T, you get 2 power of 0, okay, multiply with 1, the second value of Q is 1, so you get 1. And trivial factor is W0, you get exponent minus j 2 pi, value is 0, divided by 4, the exponent 0 and 1. For W1, you get exponent minus j 2 pi, t is 1 divided by 4, so exponent minus j pi over 2, and you get minus j. So finish stage 1, we go to the stage 2. So p equal to 2m minus I. The m is total stages, so 2 power of 2 minus 2, you get 1. And q, you only have one value, that start with 0. And t equal to 2 power of I minus 1 times with q. So 2 power of 2 minus 1 times with 0, so you equal to 0. And lastly, for the trivial factor is W0 equal to minus exponent minus j2 pi multiplied with 0 divided by 4. So exponent 0, this is equal to 1. So after you know the trivial factor, so we need to calculate the butterfly value. So we start with stage 2 first. So the A and B. So this is A plus B and this is A minus B multiplied with WT. We go back to the diagram. So based on this diagram, okay, so this is A plus B equal to 14 and A minus B multiplied with the W0 is 1 equal to 2. I assume this one is equation 1 and I assume this one is equation 2. Now, equation 1 plus with equation 2. Okay, so 2 plus 2, I got 2a. And b minus b get 0. 14 minus 2 and 14 plus 2, you got 16. So a is equal to 8. And I substitute the value of a into the equation 1. So I get b equal to 6. Okay, so I substitute the value a and b into a diagram. Next is C plus D equal to 2 minus 2j and C minus D multiplied with W0 equal to 2 plus 2j. And assume this one is equation 3 and assume this one is equation 4. So 3 plus with equation 4, So you have C plus C, you get 2C, D minus D equal to 0, and 2 plus 2 equal to 4, so equal to 4, minus J plus 2J equal to 0. So I get C equal to 2. And then I substitute the value of C into the equation 3, and I get C plus D equal to 2 minus 2J. So 2 plus D equal to 2 minus 2J. And then I get D equal to minus 2J. So C equal to 2, D equal to minus 2J. So I write down here C equal to 2, D equal to minus 2J. Now we go to the stage 1. Okay, so let's look at the pairing x0 and x2. So A plus B, you will get 8, and A plus C equal to 8, and A minus C multiplied by W0, you will get 2. I assume this one is equation 1 again. So this one equation 2. And W0 is 1. Okay, this is equal to 1. So A equation 1 plus equation 2, this is equal to 2A equal to 10. Whereas, so A is equal to 5. And I substitute the value of A into the equation 1, I get A plus C equal to 8. So A equal to 5 plus C equal to 8, C equal to 3. And then I transfer the A equal to 5 and C equal to 3 into the diagram. Okay, next we look at the B and D. So B plus with D you get 6, and B minus D multiplied with W1, W1 equal to minus J equal to minus 2J. So I assume this one is equation number 3. And okay, W1 is referred to B minus D multiplied with minus J equal to minus 2J. So I multiply in, I get minus BJ plus DJ equal to minus 2J. So this is equation number 4. Since this one, equation 3 and 4, if we compare, this is no J, we cannot compare. So we must multiply a J to equation 3. So you get BJ plus DJ equal to 6J. So this is equation number 5. So equation 4 plus equation number 5, so you get 2DJ. Okay, equation 4 plus equation 5. So minus BJ plus BJ, you get 0. So DJ plus DJ, you get 2DJ. And then minus 2 plus 6, so you get 4J. So D equal to 4J minus 2J, this is equal to 2. And then I substitute the D equal to 2 into the equation. So I have BJ plus DJ equal to 6J. So BJ plus with 2J, D is 2, okay, equal to 6J. So therefore the B is equal to 6J minus with 2J divided by J. And I get the answer is 4. Okay, 4J divided by J, so I get 4. Therefore, my Xn, okay, so before that, you substitute the value of D equal to 2 and B equal to 4 into the diagram. So B equal to 2, B equal to 4, okay, B equal to 4, D equal to 2 into the diagram. So when we name the Xn, that is X0, X1, X2, and X3. So we follow the sequence 5, 4, 3, and 2. Okay. So Xn equal to A, B, C, and D. This is 5, 4, 3, and 2. So this is the value of the Xn obtained from the DIF technique. Okay. Hope you can understand the inverse discrete Fourier transform using the DIF technique. Okay, that's all. Thank you very much.